Hey, Starship here, and today I'm going to talk about antimatter. You may have heard of this stuff before, but not really known what it is. Well, if you don't know about antimatter already, if you do, then you're smart. Congratulations! I'll explain it to you in a way that is mostly painless. Antimatter is exactly the same as normal matter, except with a reversed magnetic charge and reversed isospin. So there is an antiproton, which is a proton with a negative charge, and a positron, which is an electron with a positive charge. And with the antiproton and positron, you can make antihydrogen and antihelium. Also, there is an antineutron, which is like a neutron, and in that it has no electric charge, but it does have a reversed isospin, and antineutrinos and such. Also, I made a mistake. I said that you could make antihelium with just positrons and antiprotons, but actually you also need antineutrons to make antihelium. Now back to our scheduled programming. Every subatomic particle has a corresponding antiparticle. The antiprotons, antineutrons, and positrons can make up antinuclei. The antinuclei of antihydrogen, for example, is made up of a positron orbiting an antiproton. In most research papers on antimatter, antiparticles are denoted by putting a weird little line on top of the particle's symbol. It looks like this. Probably one of the most interesting properties of antimatter is what it does when it comes in contact with normal matter. When antimatter comes in contact with an equal amount of normal matter, both are instantly annihilated and release energy in a manner consistent with E equals mc squared. For example, 1 ton of antimatter coming into contact with 1 ton of regular matter would release approximately 3 times as much energy as if the entire American nuclear arsenal at its height in 1966, which was comprised of 30,000 nuclear weapons, was detonated all at once. Antimatter can be created using particle colliders, and can be used for many things, such as PET, which stands for positron emission tomography, which is a type of medical imaging which, well, the simplest way I can explain it, there is a type of radioactive decay in which the nucleus of an atom has more protons than neutrons, and it emits a neutrino and a positron, and in the same process, a proton becomes a neutron. This is called beta plus decay. So the radiologist somehow administers a small amount of a type of element that decays via beta plus decay, which then releases positrons. And when the positrons react with the other matter in the body, they emit gamma rays. And then they utilize a detector to locate the source of these gamma rays and variations in the gamma rays, and then feed the information through a computer, which creates a precise map of the body. Another thing that scientists have proposed is an antimatter rocket, which would use the energy from the antimatter reactions to propel the rocket. Unfortunately, acquiring enough antimatter to make this possible, and indeed practical, would be extremely difficult. The particle accelerators at CERN, which stands for the European Center for Nuclear Research, it makes sense in French, trust me, can produce about 10 million antiprotons per minute, which means that to make 1 gram of antihydrogen atoms, it would take 100 billion years. You could do a lot with 1 gram of antihydrogen, but it's probably just not worth it, considering that it would almost certainly take more energy to make the antimatter than the antimatter could actually produce through antimatter reactions. Also, some folks have proposed an antimatter weapon, though I don't think such a weapon would ever be built due to the aforementioned reasons. Also, you could just kill everyone with nukes. Anyway, that's my video. Hope you enjoyed. P.S. Bibliography is in the description.